Okay, in simple terms, we're going to look at what machine learning is. Currently, machine learning is divided into three categories. It's supervised learning, it's unsupervised learning, and it's reinforcement learning. Let's look at supervised learning. Supervised learning is when we have sample data and we wanted to extract some features from our data. For example, let's say you want to categorize between a cat, a dog, and a lion. Then we'll say whiskers, and then we'll say whether it's a carnivore or not. And we'll look at its size, we'll look at its fur, we'll look at its texture, we'll look at where it's found. Those are the features. And something we call labels is whether it's a dog, a cat, or a lion. And then we feed all this information into our model, and our model learns these things, learns the properties, learns the different properties. Currently, the main way that we do this is that we feed in pictures and we pixelate it. After pixelating it, we feed it into our model, and our model learns the different properties of the different pictures. So we feed in many pictures of cats and we tell it these are cats. We feed in many pictures of dogs and we say these are dogs. We feed in many pictures of lions and say these are lions. And the system itself learns what? And the system itself learns how to categorize the three. You see this? That's supervised learning. Now, unsupervised learning is when we have many pictures of animals and we want the system itself to categorize for us. Now that sounds magical, and it is, and it's very difficult to implement. Out of the three, that's the most difficult to implement. Because first of all, we have to extract the different categories and groups from the model ourselves. And we don't have the answers, what we call the labels, beforehand. Now, reinforcement learning, used mainly in games, is when we give a reward for each and every move that the agent plays. An agent is the character in a game. So, for example, in Pac-Man, when Pac-Man moves to the left where there's a pill and gets a point, we want to tell it that, hey, if you move to the left where there's a pill, you will get a point, but if you move to the right, you won't get a point. So we prefer you move to the left as long as there's no enemy unit there. So going back to the Pac-Man example, if it goes to the left and gets a pill, but loses a life in 5 games, but going to the right, it doesn't get a pill immediately, but never loses a life, then it'll learn to go to the right. So in reinforcement learning, what we want to do is to optimize a function that estimates future rewards. For example, if I can estimate that if I make certain moves in life, I read a book and the likes, and then it gets me better future rewards, then I'll go with reading a book an hour a day. But if the function estimates that I don't get a better life later on, then it won't recommend that I read a book currently. It'll recommend that I chow a hot dog, a pie, or a special. So in brief, that's currently what machine learning is. We'll go into depth into each and every one of these in subsequent videos. Please subscribe, please like, please leave a positive comment. Thank you.